4.3, the graph of the tangent and cotangent functions. So graph the tangent function. A vertical asymptote is a vertical line that the graph approaches but does not intersect. As the x values get closer and closer to the line, the function value increases or decreases without bound. Meaning your vertical asymptote will always approach it, but we never intersect it. You might remember this from college algebra. If you took me, you should know that your vertical asymptote never is crossed. If you've taken pre-calc or something, or college algebra, you know that you never cross your vertical asymptote. Your horizontal or oblique, sometimes you do cross those. It's rare, but you do. But vertical asymptote, you never cross that. Alright, tangent functions. F of x equals tangent x. So the domain is x such that x cannot equal 2n plus 1 times pi over 2, where n is any integer. Your range is negative infinity to infinity. So since we have an all real numbers range, that means we have no amplitude. So we're not going to find any amp here, no amplitude here. So this is what the graph of a tangent function would look like. So on your calculator, that's how it would look like if you graphed it by hand. This is what it would look like. The graph is discontinuous on a value of x of the form x equals 2n plus 1 times pi over 2 and has a vertical asymptote at these values. Its x-intercept are the form of x equals n pi. Its period is pi. The graph has no amplitude, so there's no maximum or minimum. And the graph is symmetric with respect to the origin. So remember, origin symmetry means whatever x and y we have, we also have the opposite versions of that. All right, cotangent. So f of x equals cotangent x. Your domain is x such that x such that x cannot equal n times pi. Your range is all real numbers. So the graph is discontinuous. Its x-intercepts are in the form of x equals 2n plus 1 times pi over 2. Its period is pi. There's no amplitude, and it is symmetric to the origin. Tangent and cotangent functions. The tangent function can be graphed directly with a graphing calculator using the tangent key. The graph of a cotangent function, we must use one of the identities cotangent equals 1 over x or cotangent equals cosine over sine, because graphing calculators do not have cotangent keys. Now, you're not allowed to graph these using a calculator, but you can check your calculator. You need to graph these by hand. I'm giving you this information because later on, after this class, you will be able to use your calculator. But right now, we need to know how to graph these by hand. But don't worry, you can use your calculator to check your work. Alright, how do we graph tangent and cotangent? Determine the period, which is pi over b, to locate two adjacent vertical asymptotes, solving the following equations for x. So for y equals tan bx, your bx is negative pi over 2 and bx equals pi over 2. For cotangent bx, you have bx equals 0 and bx equals pi. So you find your period and your vertical asymptotes. Your second step is to sketch your vertical asymptotes. Then we find our intervals formed by the vertical asymptotes. We evaluate the quarter points for the vertical asymptote, and then we join the points with a smooth curve. We always approach the vertical asymptote, we never cross it. Alright, let's actually practice this. Example 1, graph y equals tan 2x. So we're graphing tangent 2x. So our first thing we're going to do is find the period. So there's a formula for period. The formula is bx equals negative pi over 2 and bx equals pi over 2. So bx, it's just like when we found the normal periods, it's that number with the x. So the number with x is 2, so that's the number we're going to plug in. So we have 2x equals negative pi over 2, and then we have 2x equals positive pi over 2. So we divide by 2 for each side, and we get x equals negative pi over 4, and x equals pi over 4. Our second step is to graph asymptotes, but I don't like to graph asymptotes yet. I like to wait until we're done with everything and then I start graphing. So I'm going to move on to the third step. The asymptotes we found are these. Those are the asymptotes we found. But I like to break it up into intervals so I know where to put the asymptote. Because how do I know? This isn't 1, 2, 3. It doesn't work that way. So I'm not sure where to put it yet. So that's why we just break it up into intervals and then we'll put the asymptotes. So the intervals, we do that nifty little number line, just like before. And what do we put on that number line? The asymptotes we found. So the asymptotes we found are negative pi over 4 and pi over 4. So because those are opposites of each other, smack dab in the middle is 0. And then we need to find our first quarter point. So our first quarter point is negative pi over 4 plus 0 divided by 2, which is negative pi over 8. And then that means, so this is negative pi over 8. That means on the opposite side, this is pi over 8. So now we have all of our intervals, we can actually graph our asymptotes. So now that we have our intervals, we can put them on the number line. So we have pi over 8, and then this would be pi over 4. Then on the opposite side, we have negative pi over 8, negative pi over 4. So let's go ahead and graph the asymptotes we found. So the asymptotes are always a dotted line. So we found asymptotes at positive pi over 4. And then we found asymptote at negative pi over 4. We always label them when we're doing it by hand. Alright, now we can go ahead and find our values. So the asymptotes found in step 1 are not x values. We cannot use them because, remember, your vertical asymptote is your domain. So that's what x can and cannot be. So because we have asymptotes at negative pi over 4 and pi over 4, that means x cannot be these values. We use those asymptotes as a guideline, and it starts off our interval chart. So that means we cannot use those values. The only values we are allowed to use is everything in between. So we can use negative pi over 8, we can use 0, and we can use pi over 8. So your asymptotes, you're not allowed to use them because they're vertical asymptotes. Vertical asymptotes are never crossed, therefore x can never be negative pi over 4 or pi over 4. That's what asymptotes are, meaning your graph can never cross. So x can never be pi over 4 or negative pi over 4. So we plug it in, you use your calculator. This is coming from 4.1, 4.2, so when we plug in negative pi over 8, we get negative 1. When we plug in 0, we get 0, and when we plug in pi over 8, we get 1. So let's go ahead and graph our points. We have negative pi over 8, negative 1. Then we have 0, 0, and then pi over 8, 1. So we connect the dots, and we use the asymptotes as our guideline. So we use it as our guideline. Isn't this really, really, really similar to College Algebra Chapter 5.4? It is. It really is. We're just changing what the function looks like, but what we're doing is not any different. Alright, so we have our graph, but we can graph more. How do I know we can graph more? We have a lot of this graph extra, and it doesn't say over anything. It doesn't say over 1 period, over 2 periods, so let's graph some more of this. So we can graph more, which we should to see what's to the left and to the right of the asymptote, because right now we only have inside the asymptote, but we want to see what's on the left and what's on the right of our asymptote. So 1/2 of the period on both sides. So a period is pi over 4. It goes from 0 to pi over 4, also on the negative version. So I want to know what's halfway between those two. So what's another interval that we can have. So we do pi over 4 plus pi over 4, which is 2 pi over 4, which comes out to just pi over 2. So that means right here we have a tick mark of pi over 2. So it means on this side we also have a tick mark of pi over 2. So if we just divided our graph in half, what we have, the yellow part, if we divided it in half here, that's having this this graph. So it goes down, then up. So if I keep going, if it's going from here to here, if it's going like this, that means if I go again at this point, it's going down. And if here I go again, it's going to go up. Now, I don't know that it goes like this because I don't have another asymptote. I don't have another asymptote right here or right here. So I can't keep going with the graph. I can't do that. I would have to find some more information out. But what we can do is complete the graph on opposite sides of the asymptote following the pattern. Alright, example 2. Let's graph y equals -3 tangent 1/2 x. So our first step is to find the period. The period gives us our asymptotes. So our period, remember, it's a formula. It's bx equals negative pi over 2, and bx equals pi over 2. So in this case, our number with the x is always the b. So we have 1/2 x equals negative pi over 2. And then we have 1/2 x equals pi over 2. So we multiply by 2. And we get x equals negative pi, and x equals positive pi. Alright, so now we have our period, also known as our asymptotes, but before we actually get to our asymptotes, right, that's our second step, is to graph the asymptotes. But before we graph the asymptotes, I like to see my intervals first. So let's go ahead and do our intervals. So on our intervals, we have negative pi to pi. So halfway, because those are opposites of each other, halfway is 0. And then to find our first quarter point, so 0 to -1, that's negative pi over 2. And then 0 to 1 pi, that would just be regular pi over 2, because that's halfway, half. So remember, we actually don't use the numbers of our asymptotes. We use the numbers found in between the asymptotes. So we're going to be using negative pi over 2, and 0. So just like every other example, we plug it into our calculator. We get 3, 0, -3. Now we can go ahead and graph our asymptotes because we have our intervals and all the numbers that we need to graph everything. Alright, so we have 0, then we have pi over 2, and then we have pi. So on the opposite side, we have the same exact thing. We have negative pi over 2 and negative pi. Alright, now we can graph our asymptotes. So I'm going to graph our asymptotes in bright pink. We have negative pi. And then we have pi. Now let's plot our points. We have negative pi over 2, 3. We have 0, 0. And then we have pi over 2, -3. And remember, we connect the dots and we use our asymptotes as a guideline. So it goes something like this. So that's all our coordinate plane will fit, so no need to do for extra periods. Also, you don't have to unless it's stated. So unless it's stated, you don't need to. It doesn't say over one period or anything like that, but I just want you to know for the test, most of it is going to be over only one period. Because other than that, you're just copying the graph over multiple periods. So like we did in number 1, we won't really have to do that. It will ask if it wants multiple periods, but if it doesn't ask, just do it over one period. So the function defined by y equals -3 tangent 1/2 x has the graph that compares to the graph y equals tangent x as follows. So the period is larger because 1/2 is less than 1. So that's why our period is pretty big. It goes from 0 to pi, not like pi over 2 or pi over 4. The graph is stretched vertically because a is -3 and the absolute value of -3 is greater than 1. So that's why it's stretched a lot. Each branch of the graph falls from left to right because the function decreases between each pair of adjacent asymptotes because a equals -3 and -3 is less than 0. When a is less than 0, the graph is reflected across the x-axis compared to the regular tan function. So do you notice it went backwards this time? It went down this time, so it was coming from the up and then it went down, and it only did that because of the negative in the front. In example 1, it's a positive in the front, so you see how it goes from down to up? That's all that was saying. Example 3, we're going to graph cotangent functions now. So let's graph 1/2 cotangent 2x. Alright, doesn't change, we still find our period. So how we find our period is a little different for cotangent. So how we find our period for cotangent, the formula is bx equals 0 and bx equals pi. Our b is always the number with x, so the number with x is 2. So we'll have 2x equals 0 and 2x equals pi. So x equals 0 and x equals pi over 2. Our second step would to do asymptotes, but I like to do that last. I like to do my asymptotes last. And then our third step is still intervals. So the only thing is different is how we find our asymptote. The formula to find our asymptote. That's the only thing that's different. So we're going to break this up into our intervals. We have 0 to pi over 2. So in the middle of pi over 0 and pi over 2 is pi over 4. And then half of 0 and pi over 4 is pi over 8. So if this is 1 pi over 8, this is 2 pi over 8. That means this is 3 pi over 8. And this would be 4 pi over 8, which comes out to pi over 2. Alright, remember, we actually don't use our asymptotes as numbers. We only use the numbers we found in between. So we're going to be using pi over 8. We're going to be using pi over 4. And we're going to be using 3 pi over 8. All you do is just plug it into your calculator, plug in x. We get 1/2. Or you can say 0.5, it's the same thing. For pi over 4, you get 0, and then for 3 pi over 8, you get negative 1/2. So let's draw our intervals on our graph. We have pi over 8, then we have pi over 4, we have 3 pi over 8, and then we also have those values, our asymptotes, we have 0, and then pi over 2. So we have asymptotes at 0, and then we have asymptotes at pi over 2. Let's plot our points. We have pi over 8, 1/2, pi over 4, 0, and 3 pi over 8, negative 1/2. And we're going to connect the dots as best as we can, following the curvature of the asymptotes. Or use the asymptotes to make your curve, so I was trying to say. And there's our graph. Now, why is this backwards? Did you think it was going to go like this? Did you think the graph was going to go like this because it's positive 1/2? Now, it's not going to go like that because this is a cotangent function, which is the reciprocal, which means opposite. Example 4. So we have y equals 2 plus tangent x. So for every y value for this function will be 2 units more than the corresponding y value in y equals tangent x, causing the graph to be translated 2 units up compared to the graph of y equals tan x. So if you wanted to use transformations, the first thing that you would do, you would use y equals tan x, and then you would graph it. So that's what they did here. That's y equals tan x. Then our second step, because this 2 is on the outside, every y value moves up 2 units. And that's what's happening. Do you notice it's just going up 2 units? That's what's happening. So that's how you would graph using translations. You would just have to remember what y equals tan x is, and then move everything up 2 units. Example 5, y equals negative 2 minus cotangent x minus pi over 4. Okay, so we're working with a cotangent function here, just keep that in mind. So our first step is still to find the period. So how to find the period, it's going to be something equals 0 and something equals pi. Remember, it's whatever is with x. So whatever is with x, you put for your period. This case, x minus pi over 4 is with x. So we have x minus pi over 4. So then we get x equals pi over 4. And x equals 5 pi over 4. So now we have our asymptotes. You can sketch them if you like now, but I don't. I like to wait until the end. Alright, our third step are intervals. So we have pi over 4 and 5 pi over 4. And from there we just find our intervals just like we have been doing in chapter 4.1 and 4.2, so I'm not going to really go over that. So halfway between pi over 4 and 5 pi over 4 is 3 pi over 4. Between that, we have 2 pi over 4. And then we have 3 pi over 4. Sorry, 4 pi over 4, which is just pi. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. But we can reduce all these, so 2 pi over 4 is just half pi. And then 4 pi over 4 is just pi. Remember, we don't use our asymptotes, we use the numbers in between. So we're going to use pi over 2, we're going to use 3 pi over 4, and then we're going to use pi. So you plug it into your calculator just like how we've been doing in other classes, but remember it's not going to be tangent. So when you plug this into our calculator, it's going to be very similar to 4.1, 4.2, but this is what it would look like in your calculator. So it would be negative 2 minus pi over 4, negative pi over 4, sorry. And then all we do is just translate our points to the left. So we would have, it would just look like that. But you're not going to have to do that, don't worry. It's going to be over one period.